Hello, thanks for coming to my talk. So far, this has been an awesome day. I don't know if you guys have been to a bunch of other speeches, but everyone's doing a fantastic job, and there's a lot of learning, so that's always fun. I am Tyler, and this is creating cross-platform games with one HTML5 code base. The dream is here, and it's easy and simple, and that's not true, but I'll tell you how you can do it. And it's if you know the optimization techniques, and I'll go over kind of the planning process of how to make a game that will work cross-platform. You do have to put time and energy into responsive design and into getting it to work everywhere, but the time and energy you put into it is just a magnitude less than trying to develop for each platform natively. A little bit about me. Who's this guy? I am Tyler Smith. I am a HTML5 tech evangelist for Intel. I have previously worked at a company called AppMobi. About 7 months ago, the tools and the dev team were purchased from them, but AppMobi is still a company that does services for HTML5. I have created multiple HTML5 games that have been deployed to over 8 different platforms, and through those experiences of learning how to do that, I kind of made this presentation. So all the pain points that I had through my development process, I'll bestow upon you, so you do not have to make the same mistakes I had and had to rewrite your code, and hopefully you can get to all the platforms you want in a fairly short amount of time. If you use Twitter, I don't know if you've heard of it, it's a small company, but if you use it, my handle is HTML5Tyler. I talk a lot about games, optimizations, WebGL, OpenGL, and just fun things. So if you like beer, coffee, and coding, you can follow me on Twitter. Basic overview. So I'm not going to dive too deep into actual code. I'm going to have some pseudocode. So if you thought this was going to be me creating a game in front of you, I'm sorry, it's not. But there's a lot of caveats that you need to kind of keep in mind. One, as you plan the game you're going to create, and two, as you create the game. First thing is decide if you need a game engine. I used to say decide which game engine to use, but through the years I've realized there's a lot of times where you need to create your own based on different pain points that I'm going to go over. What you need to look for before you decide to develop for a platform. Everyone wants to be everywhere all the time. HTML5 is that dream, but there are certain caveats, again, for each platform that you need to know before you start developing for it. It is a very bad idea if you think I want to be on iOS and Android, so I'm going to make my HTML5 game on, just iOS. That's all I'm going to test on, and I'll port it to Android because it's HTML5. It's not how it works, really. There's a lot of things that Android does not like that iOS does, and I'm going to kind of talk about what you need to look for and what you need to plan in your process before you start coding specifically for one platform, and how to kind of make sure that it's going to work well on others. One of the biggest pain points of HTML5 is optimizing mobile performance. As I was talking to you before we even started, there's a lot of problems with Android and fragmented web views, and I'm going to go over a couple things that I found throughout making the different games that I have that will get you to a point where the user shouldn't know that you're using HTML5, because that is the point that you're really trying to get, where you can get HTML5 into native app stores and you can get in front of them, and you want to make sure that they're not having a less than native experience as much as you can. You kind of be like an HTML5 ninja. You're there, you're HTML5, but unless you have a flag that says it, you don't want them to know, and you don't want them to have any performance caps. So I'll go over some mobile performance techniques. There's 2 ways that you can really deploy HTML5 games. You can do through the browser on mobile and desktop, or you can do hybrid app deployment also on mobile and desktop. I'll do the pros and cons of each. I am biased. I'm going to let you know that. I've worked for a hybrid app company for 4 years now, so I will lean that way, but I will try to be objective as I can. And there are plus sides to going browser and not hybrid app deployment, but again, take what I say with a little grain of salt. I will probably be leaning in one way. And there are a multitude of things that can get performance for your game on different platforms. Again, as I was talking before this, there's several different offerings that can get your game accelerated by OpenGL and the GPU and hardware acceleration to get you to the performance that you need. And again, not to be known that you are using HTML5, and I'll go over all those different choices that you have. And then how to package and deploy your game if you do choose the hybrid app route. So first, should I use a game engine? How do I decide that? What do I need to know first? First, how complex is your game? Do you need a collision detection? Are you going to need a level creator? Do you want a sprite animator? Are you going to do multiplayer? Do you need Node.js and Socket.io inputs? So you need to kind of understand the scope of your initial release, and you want to know all of the features that you're going to need. If you have just a plethora of things you want to do and you want to take the world by the tail, may want to use a game engine because all that functionality will be built in there for you, and you don't have to build it by hand, save you a lot of time getting to market. So that's definitely one thing you need to know in order to make that decision. If you haven't made an HTML5 game before, I highly recommend using a predominant one first, just to kind of get the dynamics and get the feel of what a game engine needs to have, especially in collision detection and sprite animation. There's a lot of good ones out there. Impact.js is good. Phaser, which is open source, you don't have to pay anything for it. You can pull it down and understand. But if you've never made an HTML5 game before, really dabble with a game engine first, I'd recommend, before you kind of try to tackle it on your own. That way you can see what other people have already failed and fixed. You know, you can find the right way of doing it without having to do that yourself. Learn from other people's mistakes, really. If your time frame is 3 weeks, you probably should not build your own game engine. That would assume that was kind of common sense, but I've actually seen people try to do such things and then be very frustrated that they couldn't get to market in the very small time frame they had. So how long do you have it? Do you have 6 months? Maybe you can build it then, but time frame is definitely a key factor in what you're going to use. Then I have a fun little table here. If you build your own, again, it's going to be very more time intensive, and you're going to have to figure out everything, and you have a bug, only you are going to be able to fix that bug. You cannot go to forums or support or someone who's maintaining the code because it is your code. So then when you get into bugs, it's kind of, the buck stops with you. So if you have the time, or if you're trying to do it on the side, then by all means go for your own game engine. But if you're trying to do something you only have a certain amount of time, you might want to just use a game engine. There is a huge benefit to creating your own game engine, though. I'm not trying to say everyone use a game engine. When you have HTML5, again, optimization is key. Software rendering draw calls are key. You do not want to do a lot of software rendering, because if you do, you're going to bog down your performance. And you can optimize your game engine if you know what it needs to do for your specific game to do exactly what it needs to do in an optimized way just for you. And that will give you, one, a very lean code base, so it's not that big to download, and two, a very functional game engine for your game. Hopefully you build it in a way that you can build other games on top of it that you know how to build, but you can definitely get a way more optimized and slim approach. It'll just take more time to do it. And when you use a game engine, you get more bloat. You might have 90% of features you aren't using that the user then has to download and execute on their browser or on their app, that it's kind of no reason that it's there. So really kind of pick and choose. There's a pro and con to each way. There's no right way, as we all coders know. There's like 19,000 ways to skin a cat. And again, yeah, I already touched the lean functionality. And then with the game engine, if you do have tons of functionality that you need, you might want to put in, multiplayer down the road, or if you have scope that you want it to be like this awesome, amazing game, it's going to suck if every time you want to add something, sprite animator or Socket.io Node.js, that you have to add it manually yourself. Again, it's going to be time intensive, and it's going to get hard to get your game a new update to the market, because we all know users want their content fast and they want it good. So if you take a long time to get a new update out, especially in the iOS store, they could just not care about your game anymore and go on to something else. There are way more apps that they could be playing instead of yours. So if you decide to use a game engine, there's a whole subset of things you also need to know about it. Now, most game engines, HTML5 game engines, are designed to be responsive. That's kind of the point. But there are ones that are just based on having a square box and are based for desktop only. So you really need to make sure, if you're targeting mobile devices, do not get on a game engine that will get you to the places you need to be. Always make sure that it has maintained forums, that it's maintained by the user who created it, and that it has support from a community. The last thing you want to do is work 6 months on a game engine that really is what you need for your game. Yeah, I got everything I need, it's all in front of me, and then you hit this really critical error, and you go on the site. There's no forums. The person who maintained it now works at Google and is not doing anything with the code. It's kind of dying, and there's no community to ask. So now your game that you spent 6 months on has a critical error that you cannot fix, and that's detriment. That's also happened to some people I know. So really research the game engine before. There's probably like 100 different HTML5 game engines right now. And a lot of people just kind of make them and put them up on GitHub, but make sure there's a community. Make sure people care about that code base before you start building on it. I put in debugging tools because that totally helps when you're trying to find out why your game is running at 2 frames per second on a mobile device. I wouldn't say that's a deciding factor. Like if there's no debugging tools, I'm out. But it's definitely a cherry on top. It's going to make your life easier when you're trying to deploy, and it's totally going to make your life easier when you're looking at an Android device and you have no idea why when you have 2 entities you're getting like 3 frames per second. So debugging tools are something to look at. I put cost on here. It's really going to be less than $100. Even indie devs could probably scrape that together in a couple months. So it's not too expensive at this point, but it is a factor. And there are great HTML5 game engines. Again, Phaser is open source. You can download it. I think they just came out with Rev 1.0, and it's pretty nice. So there are alternatives that are free. Most important for me, does it run well on mobile? Again, if it can responsively change to the screen size, but then the performance is just horrible on it because it's 60 megs big and they have to download everything again and it has to extrapolate and it just does not work. That's an issue. So you need to make sure that it can, again, get to the platforms that you want to get to. Make sure the game engine is versatile and will fit for your game. And does the game engine allow pre-rendering? When you're doing browser deployment, and UI web view deployment, it's extremely important to, again, save draw calls. And I'll go into kind of different techniques of pre-rendering later, but if the game engine will pre-render for you in the background default, that's awesome. That saves you a lot of work and you don't have to make off-screen canvases. And again, I'll go over that later, but it just saves you a lot of work. You really want to research the supported platforms. If you're on a desktop and you okay, I'm gonna build it in Chrome and then I'm gonna deploy it to mobile. I'm gonna go to Android first, then iOS. That's great. You have to think about how this is going to translate to the user as the same experience. When we created Boomtown, which was a game, simple puzzle game, but it was deployed to 8 different platforms. We did deploy it to Facebook and we did deploy it to Chrome Web Store. Now, we saw a lot of users who liked it on iOS play it on Facebook. So if you have a game that's playing really well on iOS, but then the game mechanics are completely weird and the controls don't really fit on a desktop, you're not going to get that user acquisition across platforms. And that's one of the beauties of HTML5. You have a good game everywhere, so I can play it anywhere. So I want to be able to understand what I'm doing. I can get right into it. I've already played and beat the game on iOS. Why should I have to relearn the controls on Facebook? So really kind of it's hard to do because WASD and a mouse is totally different than a touch interface. But you should do some user testing, kind of give it to your mom and dad, probably not the right people, maybe your kids, and let them test it, see how complicated it is to go between platforms, because that is an issue if you want to get people cross-platform to use it. Will it use multi-touch is a issue if it's just one click, and that's fine. But if you have a jump and run game or a platformer, the UI web view of Android does not support multi-touch. So you will have issues when you're trying to do a jump and run game and you can only jump and can't run. That's not a fun game. You will stand still. So make sure that if you're using multi-touch, I'll get into different alternatives that you can get multi-touch on Android. But if that is an issue, make sure that's in the back of your mind when you're programming. It is important to know if there's HTML5 support on the platform you're going for. That is, again, one of those things you should probably know beforehand, but it's worth saying. Does it support the canvas tag? It might support the canvas tag, but not the audio tag. There are a lot of fragmented, weird versions of Android out there. Audio is kind of an immersive game experience. If you have just a visual and no audio, it's going to be less immersive for a user and not as fun. And that's really the end result, is we want people to have fun. We want to make games that they enjoy and maybe get paid eventually, but it's HTML5, so probably not. And the last thing is screen width and height. Who here thinks screen width and height is a problem for HTML5 developers and or a headache? Raise of hands. I got a half hand raise, and I'm glad. I got a bunch of them. I got a bunch of them. Thank you. This is a ratio of a portrait game. So if I'm developing for a game, and I develop first for iPad, and then I port it to iPhone, I'm gaining screen space. That is awesome. So I can see now my user who's playing the same game on iPhone, I can pop in an ad. I can actually make money this way. So the last thing you want to do is leave that little blank space black, because then the user knows, okay, well, this isn't a native game. There's something weird with my screen. A user really doesn't understand programming, so they won't understand why there's a black bar. And then when you get to Android, you're just gaining more screen. If you've developed for Android first, you're losing screen. So you really have to make sure that your game mechanics, your position of your controls are adaptive to the environment that they're going to be played in. Especially screen width and height is really, really important to test before you deploy. When we go to landscape, it becomes more of a detriment instead of a tiny headache. When you can see, if I would make my game for iPad and then I deployed it to Android, I'm losing more than 1/3 of the screen, and that's crazy. You really have to make sure that you pre-thought how your game is going to adapt to having almost 1/3 of the screen gone. And that is one of the issues that we found in Boomtown. We did deploy it to Nook, we deployed it to Amazon Kindle Fire, and we deployed it to iPad. So when we were on an Android, I think it was just a Droid in the middle, we decided that we needed to have a responsive design. So we took out all of our devices that we had at AppMobi at the time, and we made a bunch of just regular HTML divs, and we set it in the center, and we found what is the minimum amount of space that every user can see. What is the board that everyone will be able to play? Maybe not see the whole screen, not see the whole ambiance that we'll put on it, but what do they need to play? And that's kind of what we did with the game board. You can see at the top, we have a cowboy hat. We got a barrel. There's a sunset. That's a pretty awesome game. But if I go down to Android, I still can play it. I can still click. It still works. I can do everything I need to do. It might look a little bit not polished, but it still gives the user an experience and a gameplay. They can play the game. And then we go down to an iPhone. The hat's a little cut off, but it would kind of look like that. It kind of looks like that you tried it. So that's one way that you can actually adapt to different screen ratios. If you have a platformer game, you just have to control where the camera goes and make sure that typically, if you have controls, just position absolute, bottom 0 pixels, right 0 pixels. You can keep it in the corners or have it somewhere in a responsive way that will always stay in the screen. The last thing you want is half a button on a screen and the user's trying to scroll the screen up to try to even play your game. Frustration will happen, and then they'll delete your app and just tell everyone how bad it is. That's happened to me. So finding the screen width and height is probably one of the worst things to do on Android in ever. Seriously, is probably the worst part about developing for it. But I luckily found, I made a snippet eventually that actually got me the right width and height. The issue there is on some Androids, if I have it's an iPhone, but let's just pretend this is an Android. If I have a game that's on landscape, and I ask window.innerHeight, some will give me the height of the physical screen device. Some will give me the height of the screen device in orientation. Some will return nan, because that's not a thing that I should be asking, apparently. And then some will only use screen.width and height, and the same thing happens on both of the calls. So this will actually, I literally wrote there's a website called HTML5 Hub. There's a whole article just describing why I came to this conclusion and how to do it for your app. And then there's also another really cool article about how you can scale your canvas to the screen of the device. That came out like 4 days ago on HTML5 Hub. Both really good reads if you're trying to deploy HTML5 games across browsers and across hybrid deployment. I'd recommend looking at HTML5 Hub for those. But there's a lot of information out there on how to get the right screen width and height. But that is probably the biggest headache for games, because if you return the wrong value, your game's going to look horrible because the canvas doesn't understand it's drawing off screen. You have to make sure that it doesn't. So pre-rendering backgrounds. This is a demo from Impact.js. It was their old jump and run demo. But their game engine actually did background pre-rendering. And I like using it as a demo because it's a pretty good aesthetic. But you can see in the top left, they pre-render the background. So what they do is they take that little chunk that you draw there, and when it's playing on the game, they'll draw another piece of canvas that's a size off of the screen, so it does not have to software render to the screen. You get no performance bump or performance gap, and then it saves it as image data, and then you just draw it back onto the initial canvas. So instead of having to draw everything again back to the screen software rendering, you're only doing a couple draw calls to draw the whole background again. And we've literally seen games go from 2 to 5 frames per second up to 15 frames to 20 frames because it doesn't have to continually draw. Again, software rendering to the screen is the biggest detriment in mobile performance, especially with games. So you can see here, I have a repeating background that's working all the way across, and I don't really have to do too much with the software rendering, so I get better frames per second. A while ago, I was given the beautiful task of developing for Nook Color right when it came out, and it was running Android 1.9, I believe. And we had to make an HTML5 game for it. So it didn't work initially, obviously, but what we were getting is this is a game called Jelly Blocks, and it basically works like Bejeweled. If I would click that red square that's in all of the yellow columns and I'd move it, after I get 3, pop, it comes down. But the problem we were having is if I was a user and I hit that red square and I moved it, it would be a literal 2-second delay before anything happened. So the user would just hit everything, and then like the calls would stack sky high, and then everything would just like literally explode, and Nook was everywhere. So what we had to do is we realized, okay, so every draw call, I'm drawing that jelly block, I'm drawing that key, I'm drawing that X, I'm drawing that volume thing, but when he's touching the screen, I know there's 2 things that need to be animated, that row and that column. So why am I wasting my software rendering draw calls on the rest of the screen? So we went into the game engine, and we hacked it a little bit, and we made sure that when that finger was down, the only thing updating on the draw calls on the screen were that row and that column. And we went from literally unplayable, 1 to 2 frames per second, all the way up to 25 frames per second, 30. So at that point, the player could hit it and they could drag it across. There would be like a, maybe 500 millisecond, 200 millisecond delay, but to a user, it still worked. They didn't get crazy and start flipping out and trying to do everything to see if their touches were even being registered. So if you're having really big detriment to your mobile performance, maybe there's something on the screen you don't need to draw anymore. Maybe if you have a scoreboard at the top and the score only changes when you get a point, only redraw the top of the screen when you get a point. There's ways that you can save software rendering. For size optimization, especially if you're deploying through a mobile browser, you do not want a big size of a game. If the user has to wait over 8 seconds, I guarantee like almost no one's going to play your game. People need their things right now. If you don't have a first paint, you don't have a loading screen, they're going to leave. So the first thing you need to do is try to get the smallest size of your game, the smallest possible bundle size. When we created Boomtown, again, we back then the biggest bundle that could be downloaded over 3G was 25 megs. And that, I don't know, the friction drop off of people downloading over Wi-Fi, I think is like 40 or 45%, because no one's on Wi-Fi, they just want to download an app, so they will never come back to it. So we needed to be under that 25 meg limit. And we were probably at like, I think 35, maybe 40. So number one thing, pull your sound out of your binary. You do not need sound in there. If you have maybe like little blips, like if you're like really 1 meg, okay, maybe like 500K. But if you have like a 5-minute background track, just take it out. You can dynamically cache on device. It'll also save you time or save you space, especially if you're trying to deploy across browsers. So if you have Firefox, you have to have OOGs, and then you have to have MP3s for the other ones. Take all of that out. You can dynamically cache based where you're at. So if I'm on mobile Firefox OS, I'll cache my OOG file. And if I'm not, I'll cache an MP3. If I'm on a browser Firefox, again, OOG, if not MP3. That way, I can dynamically cache. I can do things with the user. They can see the title screen. But you can just get all of that giant size of sound files out of the way and just get it onto the device, into the device's cache. And then that way, if it is a hybrid app, when they play it again, it'll just call right from the cache and you have no problem. There's no delay time. Another thing that we had to do, our graphics department hated us, but we turned JPEGs, we used JPEGs instead of PNGs when we were able. Obviously, you're not going to make a sprite sheet a JPEG. That just doesn't work. But if I'm looking at this, yeah, that looks awesome. I got the burnt edges. I mean, yeah, it's like totally fade. I got the alpha, you know. But over here, I don't have the alpha, and it still works because I'm an engineer and not a graphic designer, and they both look the same to me. What looks even better is the fact that I've shaved off more than a tenth. It's less than a tenth of the original image. So I've shaved off a lot of size. We actually got rid of, I think, 10 megs just by changing a lot of our UI to flat JPEGs and not using an alpha. Yes, the graphics department will egg your car, but at the end of the day, it's all right because you can get download over 3G. Right, and nowadays it is 50 megs, I believe, over 3G and not Wi-Fi. So we've gotten the ceiling raised a little bit, so that does help. So should I deploy through a hybrid deployment or a browser deployment? I'm objective. Let's find out. When you have a hybrid deployment, you are benefited in having the same exact distribution model as native. You can just type in your Apple password and they'll download the app and you'll get $1. Awesome, 70 cents really, but it's good. You can have native in-app purchasing. There are libraries AppMobi supports. Literally, you tie into one JavaScript library, and then when you build through the Intel build system, it will have the native payment experience on every platform. We did that with Boomtown. When I was in the Chrome store, you could pay for more coins with the Chrome payment system. When I was on iOS, it was native iOS, native Android. So the user doesn't even understand that you're using HTML5 because there are native services out there that can make in-app purchasing work exactly like a native experience. And that is going to be very, very low friction, and you're going to get a lot more revenue that way. Browser deployment right now, the only thing you can really do is maybe paywalls and HTML5 ad networks, both of which are not as seamless and not as frictionless as native in-app purchasing. So it'll be harder to make money if you do strictly browser deployment. The one big thing to me is if you want to make your game social and you want to make them, post to Facebook, post to Twitter, Instagram, everything. What's awesome in hybrid app deployment is I can use native JavaScript APIs to call the Facebook app. So all I do is like, hey, sign into Facebook. They click it, pops over to Facebook, and will pop back. They don't have to do anything. Awesome. There's zero friction to that. When I'm in a browser, they get a new tab and they're going to have to sign in and manually type in the stuff. You just lost like half your audience. People don't like doing things. So you have to try to make them do less things and more people will pay you. Hybrid app deployment, we do have full screen. You can get rid of the status bar and you can get locking orientation. All of these things are amazing for games. Without locking orientation, that's just a detriment. If you're on landscape and they're laying in bed and they actually go to portrait, your canvas is going to try to repaint if you made it responsive design in the wrong orientation, and it's probably going to crash the browser because you're doing so much things all at once if they were in the middle of playing, and it's going to be a bad experience. There is no more full screen in iOS 7. We had it. But, and there's no locking in orientation. So as the future apparently is grimmer in the future of iOS 7, you might want to look more at hybrid app deployment if you want to give the user a more immersive experience on their phone. You have access to hardware acceleration in hybrid app deployment. There's Cocoon.js, there's app game interfaces, there's Ejecta, and these are all going to use the GPU to actually render your game. In browser deployment, though, the Nitro in Safari is leagues better than the UI web view in Safari or in iOS. They kind of crippled the web view in iOS, and the V8 engine in Android is a good accelerant. So even though you don't have access to native acceleration, there are good JavaScript runtimes. Hybrid deployment, you have native OpenAL sound. You can do polyphonic sounds on a background sound. You can do 10. You can do 10 sounds at once. That's amazing. You can, I guess, on audio tag, but you're gonna spend more time on that than probably making your game engine. So the audio tag support, especially on mobile browsers, is very poor. But hopefully in time it'll get better. But you do have a more immersive sound when you do hybrid deployment. Now this is hybrid deployment on desktop. The previous was on mobile. There are two ways that I know of. I'm probably sure there are more. I'm sorry if I didn't mention them. Osmium and Node WebKit. Basically, they take a version of Chromium and they package it in an executable or a DMG, and you can actually have an executable of an HTML5 game sitting on your desktop with an icon, which is really cool. There's a less fragmented environment when you do that. You don't have to worry about if they're using Firefox or if they're using IE7 or if they're, just they made their own browser and they're trying to play your game and they're mad it doesn't work. That won't happen. With browser deployment, you do have the multiple browser issue and fragmentation issue, so you're going to have to test your game on every different browser under the sun, and that does get mind-numbing. You have access to the local machine sources. It has Node.js in the Node WebKit, and you can actually access local files. You can touch things on the computer that you cannot do through a browser, which is pretty cool. And you have a desktop icon. You don't have a bookmark in a web view. You don't have a bookmark in a browser. You can literally say, hey, I'm on your desktop. That's screen space. The same thing happens on iOS, but when you bookmark on iOS, you actually get an icon. But for desktop, the usability, the probability of people playing your game more than once has gone up because there's literally a reminder every time they look at their screen. So for hardware acceleration, which I've talked about already multiple times, I'm just going to talk about it again. It's in my slide. Its graphic acceleration speeds up HTML5 2 to 10 times. Again, it's typically porting over to OpenGL, and it's getting a hardware rendered of your JavaScript runtime. It does have multi-touch support for Android. If you deploy with app game interfaces, Cocoon.js, or, well, Ejecta's not on Android, but you will get multi-touch. You can do that jump and run game you wanted with good performance, and the person won't actually know it's not native. So you can get good performance, you can get good usability and good interactions. It's still write once and deploy everywhere, asterisk. Because when you do this, you are now tying yourself to a third-party build system or a third-party app. So you're working inside another environment. And you have to code kind of to them. So Cocoon.js and app game interfaces both have a little bit of syntax difference. I think Cocoon's pretty simple to change, but there's still some caveats. But you won't be write once deploy everywhere. You'll probably have to adapt your code a little bit. WebGL support. That is cool. It's, with Ejecta and with Cocoon.js, they have WebGL support. You can do some pretty neat things on a mobile phone now. So you can actually make 3D, probably not really intensive games, but you can do 3D things and have people interact with them, and it'll work at an okay frame rate. So WebGL on mobile is really cool. Deploy. How do I get it onto the stores? PhoneGap has a build system. If you're doing a hybrid app deployment, you can build iOS, Android, BlackBerry, Windows Phone 8, WebOS, and Bada. I think BlackBerry support is 10, but I'm not 100% sure. And there's no accelerant when you go through their build system, but you can build games using iOS and Android for PhoneGap. The Intel XDK has a build system. And app game interfaces is built inside it. So if you want to use it to get OpenGL acceleration, you can. Deploys to iOS and Android with AGI if you wanted to use that. And then we also deploy to Amazon and Nook. That's also with AGI actually because they a version of Android. Windows Phone 8 and Windows 8 we deploy to, but you don't actually need app game interfaces. We had a very intensive game. It's called Atomic Robo Violent Science. It's extremely really well done. It's all made in HTML5, and they used app game interfaces. We deployed it to iOS, and then they deployed it to the Windows 8 store, and we were running it on the Surface. And the iPad, and it was, I think, an iPad 3 or whatever it's actually called, and it was running slower than the Windows 8 version. The Windows 8 version was just HTML5, and that made me extremely happy. These operating systems are making HTML5 fast. They're giving us hardware acceleration. They're giving us what we want. It's just taking time. So all of those accelerants are probably going to be stopgaps until Android has caught up and uses Chromium as their default UI web view, and as the device's GPU gets faster and the RAM gets bigger. But Yeah, when you build for Windows 8 and all in HTML5, you're probably going to get some pretty good performance. We also support ties in Facebook, Chrome store, and just a general web app. If you want to make a mobile game as a web app, we'll auto-generate a manifest file for you guys. Cocoon.js deploys to iOS and Android, and as I said, they do have WebGL support, which is pretty cool. Ejecta, which was actually from the creator of Impact.js. It's an open source project, also really cool, and they have WebGL support. And Ossomium, which I touched lightly, and they build exes and DMGs, executables and DMGs. So you can get, again, a compiled looking finished executable, and you can even submit that to Steam. You can have the distribution model of anyone who wrote in C#, all with HTML5, and I think that's really cool. The way that HTML5 is going, it's becoming the language, especially in games, that you can write once and deploy everywhere. And that's it. Does anyone have any questions?
I was curious about your point earlier about compressing image sizes. I get if you've got like a square image and you don't care about transparency in that case, that yeah, you go with the JPEG, it would usually be smaller. In my experience, though, if you're tweaking something like a PNG8 file, you still have to adhere to some of the same principles with the transparent edges. It's not going to work. But if you change your number of colors that you're using in the PNG, you might be able to get something smaller than JPEG.
Would it look?
Like a hard, fast ruler.
Would it look saturated?
You have to change your perceptive way, the way in which you're choosing which colors you're playing with.
So if you need to optimize your size of your image, you can also change the colors that you're using in PNG8. I just learned. That's awesome. I did not know that.
I had to go back and forth a lot for a Flash game actually.
All right.
Got similar constraints.
That's awesome. Yeah, I will actually say that next time. Thanks.
Do you have any concern for powers of 2?
Yeah, okay. That's a good point. When you use GPU acceleration, as I'm assuming where you're getting with that, there is a caveat. Let me go back to that. There's a big caveat that I didn't touch for some reason. I don't even know where it's at. Somewhere in here. Let's just stay on this slide. Yeah, so when you're using OpenGL and or Cocoon.js and app game interfaces, when you're loading images, it's not a website. You can't just load in a bunch of images. Everything has to be in the power of 2. So if you have an image that is, say, 1050 by 1050, that's going to create a memory image on OpenGL of 248 and 240, or 2048 and 2048, because it has to be in OpenGL. It has to be a power of 2 loaded into memory. So when you load, say, 15 images that are not optimized for that port, your memory is going to crash. And we get a lot of people who do that with app game interfaces. That's most of my time on the forums, is telling people how to load their images correctly. Because again, OpenGL isn't the web. So if I would make it 1024 by 1024. Perfect. That's an optimized sprite sheet. So one of the things we recommend to try to avoid loading a lot of images into memory is make an optimized sprite sheet for everything in 1024 or in 2048, so that you can, I forget what you call it. It's not aliasing. It's atlasing. Thank you. Yeah, so you can atlas to each of the images, and you can use every square pixel that you loaded into memory, because memory is another big detriment to HTML5, especially when you're using OpenGL, because it will crash. Especially if the user has no idea and has Facebook open along with like 50 streaming video apps in the background, and then they try to load up your OpenGL game and load like 19 images into OpenGL. It's just going to crash and have an explosion. So thanks for the power of 2. I forgot about that.
Well, because it makes it difficult when you say move everything to JPEG. I mean, you have to have a whole sprite sheet of stuff that doesn't have alpha.
Right.
That's difficult.
Right. That is true. I'd say I think what we do is typically with app game interface, you can have the user interface in the DOM. There's 2 contexts. There's OpenGL context and there's a DOM context. So you can still have divs. You can still have images loaded exactly as a web view. It's actually a UI web view on top of an OpenGL layer. So you can do that, and then whenever you hit a button, there's bridge calls that will call down to the JavaScript runtime, and it will calculate whatever you touch to talk to the actual OpenGL rendering. So
Similar to Cocoon.
yeah, I think they're default not WebView, but then you can call WebView if you want one.
Yeah.
Right. Yeah, we created it about the same time. We took different paths. So you kind of have a bunch of different options based on what you want to make your UI in. Any other questions? All right, thanks guys for listening.